All right. Today we're going to talk about the complex number system. And in talking about the complex numbers, what we're going to see is that there will be a real part and an imaginary part in our complex number. So consider the number 5 plus 2i. Because 5 is a real number and 2i is a pure imaginary number, they are not like terms and cannot be combined. This would be like saying 5 plus 2x. Can you put those together? No, you cannot, because they're not like terms. Alright, this type of expression is called a complex number. The standard form of a complex number is a plus bi, where a is the real part, and bi is the imaginary part. Okay? Alright, now, we are going to learn how to do operations with complex numbers. This is so simple, it doesn't even need an explanation. All it requires for us to do is combine like terms when we are adding and subtracting. So simplify the expressions below. Your final answers must be written in a plus bi form. So let's do it. So when I look at these parts here, notice that these two complex numbers are both in parentheses. Do we have to keep these in parentheses? No. But it just helps us to kind of keep things organized if we use the symbols, the parentheses. So we're going to add the parts that are alike. The negative 11 and the 9 are alike. So that gives you what? Negative 2. Alright guys, y'all make sure you're paying attention to this. Alright, and then we're going to add 3i and 2i. And that gives you what? 5i. Now, we cannot combine the negative 2 with the 5i. Okay, so for number 2, same deal. You're going to add the real parts together. 4 plus 7 is 11. And add the imaginary parts together. I minus 5i will be negative 4i. You always want to write this in your standard complex form. That is, the real part goes first, then the imaginary part. Okay, number 3. Hopefully you can see that. Alright, 7 minus 2. Now look, anytime there is a minus outside the parentheses, what does that minus do? It changes signs inside the parentheses to the opposite. So, I'm going to go ahead and change these signs. When you change the signs, you also change the sign that was on the outside, like I've done here. Alright, so 7 minus 2 is 5, and negative 2i minus 6i is negative 8i. And there you go.
You don't change the signs of the front ones.
You do not change the signs of the front ones. Only the part that's after the minus. Okay, so in number 4, we're going to change the signs in the parentheses after the minus, but not the second set of parentheses. Only this set of parentheses. So, change your signs. So now I've got 6i plus I minus 3i. So 7i minus 3i is 4i. And then negative 14 plus 5 will be negative 9. Now, is that in the proper form? No. We want our real part first. Now, is this a 9? It's a negative 9. So when you swap them, you've got to swap the negative sign with the 9. The sign always goes with the number after it. So this is really negative 9. This is a positive 4i. So negative 9 plus 4i. That is a simple thing that students forget all the time. Alright, multiplying complex numbers. Now, a lot of times when we multiply complex numbers, we're going to have to do double distribution. Double distribution is just the FOIL method. Okay? For these first ones, we don't need double distribution. We just need a single distribution. Recall what happens when you deal with your i's. Okay? Recall that I to the first is I. I squared is negative 1. I cubed equals negative I, and I to the 4th equals 1. Now, we most likely won't be dealing with all of these cases when we're doing these problems. We'll probably only be dealing with the first 2 cases. Really, in many cases, just this one. Alright? Alright, so 2I times 8 is 16I, and 2I times negative 3I is negative 6I squared. Alright, so you can see that there is part of this that needs to be simplified. We don't want to leave it as I squared. So if you see an I squared, what is I squared? Negative 1. So all that does is change the sign and get rid of the I squared. So it's going to change this 6 to a positive, and it's going to get rid of the I squared. And then I need to rewrite this in the standard form. So 6 plus 16I. Anytime you have an I squared, it's going to change the sign of the number that is with it and get rid of the I squared. Okay, let's do the second one. Distribute the negative I. So you're going to have a positive 2I and then a negative 10I squared. So what happens?
You gotta do the
same thing. So you're going to cancel your I squared, change the sign of the 10, and then 10 plus 2I. On number 7, you've got to FOIL this. Now, you can think of it as FOIL, or you can think of it as double distribution. I don't care. It's the same thing. 7 times 4. 7 times 4 is 28. 7 times negative I is negative 7I. I times 4 is 4I. And I times negative I is negative I squared. So, we've got 28 as our whole number, but we can convert this I squared to what? There's a 1 here in front of it, right? So we can cancel the I squared and make this a positive 1.
You can just combine what terms there.
Exactly. 28 and 1 is 29, and then negative 7I and 4I is negative 3I. Okay, do number 8 on your own. Okay, so first, 2 times negative 5 is negative 10, and 2 times negative 3I is negative 6I. Negative 4I times negative 5 is positive 20I, and negative 4I times negative 3I is positive 12I squared. Now, part of this can be simplified because of the I squared. So that's going to cancel out and change the sign of 12 to a negative, or to the opposite. So negative 10 and negative 12 is negative 22, and negative 6I and positive 20I is 14I. So how many got that right? Good. Why? All right, try number 9. Alright, so in number 9, this is a complex number that has been squared. I'm going to write it out with both sets of parentheses. So it's 6 minus 2I times 6 minus 2I. So then, first, 36. 6 times 6 is 36. 6 times negative 2I is negative 12I. Negative 2I times 6 is negative 12I again. And then negative 2I times negative 2I is positive 4I squared. So the I squared is the part that we need to get rid of and change the sign of the 4. Alright, so then 36 minus 4 is 32. And then negative 12I is negative 24I. And this is in the correct form. Alright, number 10. It's just more of the same. You just got to make sure you do all the changes that need to be made. Okay, so first of all, we're going to FOIL this. So, John, we're going to do 1 times 9 is 9. 1 times 3i is 3i. 7i times 9 is 63i. 7i times 3i is 21i squared. Now, let's go ahead and do this one also. Simplify this because we got to change our signs. It's going to be a negative 4 minus 2i. Alright, so having done that, now we can change our sign here because of the I squared. That changes the sign of the 21. So let's combine our like terms. 9 minus 21 and minus 4. So that's going to be negative what? You got negative 25 and positive 9. That's negative 16. So we did just, to start with, we did the whole numbers, or the integers. Next, or the reals. So then, now we deal with our imaginaries. 63i minus 2i is what? 62i, right? 64i. Yep. There you go. Alright, so there you go. Alright, now, adding, subtracting, multiplying is very straightforward. Dividing is a little bit more involved, but it's not hard. You don't think of it as being hard. So let's flip the page. All right. Now, so the complex conjugates are simply two imaginary numbers that are only different by the middle sign. That's the only difference. So, two complex numbers in the form of a plus bi and a minus bi are called complex conjugates. What this does is it enables us to eliminate the imaginary part. If I multiply complex conjugates together, the imaginary parts go away. And we'll see why this is important when we deal with division. The product of two conjugates is always a real number. That's extremely important. This is why it's important. When I divide complex numbers, I am not allowed to have a complex number in the denominator. Imaginary or complex. Not allowed to have it there. So in order to get rid of it, all I have to do is multiply it by its conjugate. And then the imaginary parts go away. But if I multiply the denominator by the conjugate, what do I have to do to the numerator? I have to multiply by the same number, right? Because I have to stay consistent. I can't multiply by the numerator and not the denominator by that same number, or the denominator and not the numerator. I'm changing the way it looks, but I don't want to change the value. So multiplying by 1 doesn't change the value, does it? So if I did 4i over 4i, did I change the value? What's 4i over 4i? 1. Does multiplying by 1 change the value? No. Okay, so that's why we need to multiply the numerator and denominator by the conjugate of the denominator. Now, we're going to get there in a minute. First, let's multiply these conjugates right here. So, we got 8 times 8, 64. And then a times negative I, negative 8i. And then I times 8, positive 8i. And then I times negative I is negative I squared. Okay, so what happens is, don't forget there's a 1 in front of this I squared. The I squared cancels and changes the sign of the 1. The negative 8i and the positive 8i go away. So what we're left with is 64 plus 1, which is 65. That's it. So notice that the product of two conjugates is real. Alright, y'all do the next one on your own. Okay, so in number 12, we're foiling. 5 times 5 is 25. 5 times 4i is 20i. Negative 4i times 5 is negative 20i. And then negative 4i times 4i is negative 16i squared. Alright, so we can simplify. I squared cancels. That changes the negative 16 to a positive 16. The 20i and the negative 20i cancel. 16 and 25, 25, 16 is 41, and that is your answer. Now, knowing how to multiply conjugates is extremely important, because this will allow us to divide imaginary and complex numbers. So, here we go. Dividing complex numbers. Alright, what are we watching out for? The I cannot be in the denominator of a complex number. You're not allowed to have an I in the denominator. Therefore, if the denominator has an I, you're going to have to multiply the numerator and denominator by the conjugate of that denominator. If the denominator is a monomial, like 2i, then you just simply multiply the top and the bottom by I. Or you can do negative 2i. I'd rather you do the conjugate, negative 2i. If the denominator is a binomial, multiply top and bottom by the conjugate. Alright, so let's do it. So, I can't have this I here, so we need to multiply by what? By negative 2i, which is the conjugate. And again, it'll work if you just multiply by I. But I like to get in the habit of multiplying by the conjugate. So, 10 times negative 2i is negative 20i, over 2 times negative 2 is negative 4i squared. Now, what happens to the I squared? Changes the negative 4 to a positive 4. So now the final simplification, negative 20 divided by 4 is negative 5i is our final answer. Y'all do number 14. Okay, so in this problem, the conjugate of negative 9i is positive 9i. So we're going to multiply top and bottom, numerator and denominator, by 9i. So this gives us 36i over negative 81i squared. Now, what happens to the I squared? Cross out, change the sign. So, this can be simplified. 36 over 81 can be reduced to 4 over 9, I believe. Right? But this time, it's 4i over 9 instead of 4 over negative 9i. Okay? So you would just leave it like this. As long as the I is in the numerator, you're good. It's just that the I cannot be in the denominator. Alright? I'm going to do number 15, and then I'm going to skip from 15 to 17. Alright, so number 15, we need to get rid of the 4i in that denominator, so what do we multiply by? Negative 4i. Now, technically, you would still get rid of the I if you just multiply by I. But, I like to get in the habit of doing it the same way every time, because when we get down here to these other ones, we're going to have to multiply by the conjugate no matter what. Alright, so, number 15, we're going to multiply by negative 4i. So, remember that this is a binomial right here. So this is going to be 28 times negative 4i. It's not minus 4i, it's times negative 4i. So negative 4i times 28, negative 112i, and then negative 8i times negative 4i is positive 32i squared. And that's over negative 16i squared. So everywhere there's an I squared, what does it do? Changes the sign. So that's now a negative 32, and this is a positive 16. So what we have is a negative 112i minus 32 over 16. Now, this is not in simplest form, because all three of these numbers have a common factor. And it's not even in standard form either, because this real part needs to be in the front. We'll fix that in a minute. What common factor do all three of these numbers share?
4. 8. No.
I think 4. I think 4 is good. Let's see if 112 has 8. Yes, 8 is the common factor. So, what we're going to do is we're going to divide all of these numbers by 8. So 112 divided by 8 is 14, so this is going to be a negative 14. This is going to be a negative 4, and this is going to be a 2. Oh, we can go even further. Okay? So, we can go even further because they're all divisible by 2. So this is going to be a negative 7 and a negative 2. Now don't forget it's negative 7i. So we're going to end up with negative 2 minus 7i, and that's it. There's nothing in the denominator. If it's a 1, you don't have to write the 1. I went ahead and wrote this in standard form with the real part first. So if we had been a little bit more careful, we would have seen that there was a common factor bigger than 8, and it would have been 16, I believe. 112 divided by 16 is 7. All right, number 16. We're going to skip that for a minute, and we're going to go down to 17. All right, so when we look at number 17, here we have a true complex number. In other words, there's a real part and there's an imaginary part. So we're going to multiply the numerator and denominator by 5 plus I. And this is going to eliminate the imaginary part in that denominator. Now I'm going to show you a little trick here. I'm going to save you a little time. In the denominator, I don't have to go through the full FOIL method. All I have to do is multiply the first terms together and the last terms together. So 5 times 5 is 25. Negative I times I is negative I squared. Because if I do the full FOIL method, this is what I end up with anyway. Anytime I multiply conjugates. So with that said, let's do the numerator. Negative 2 times 5 is negative 10. Negative 2 times I is negative 2i. Okay, what can we simplify? Remember, there's a 1 here.
The I squared.
I squared changes the negative 1 to a positive 1. So we have a negative 10 minus 2i over 26. Now, is there a common factor? 2. Divide them all by 2. So negative 10 divided by 2 is? Negative 5. Negative 2i divided by 2 is? Just negative I, right? And then 26 divided by 2 is? 13. Now, look at this form here. I'm going to let you leave it in this form, but this is not what people would classify as the purely standard form. This is technically not in standard form. Let me show you what would be standard form. If I were to break this fraction up and do it like this, negative 5 over 13 minus I over 13. That's your standard form. Anytime you have a denominator with a numerator that consists of a binomial or trinomial or whatever, you can break it up like this into 2 or 3 parts, whatever. Here it's 2 parts because there's 2 parts in the numerator. This is your official standard form because look what I have. I've got a real part and I've got an imaginary part, and the imaginary part has the I attached to it. Okay?
So we can do it that first way.
Mm-hmm.
You won't take off?
Yeah, you can leave it like this.
Okay.
Alright, I want you all to try number 19. The mistake that I'm seeing is that a lot of you are trying to multiply the numerator like we do conjugates. It doesn't work that way if you're not dealing with conjugates. So we're going to have to multiply the numerator and denominator. Notice I put these in parentheses because I want to remember that I have to deal with both of these. But when I multiply by the conjugate of 2 plus I am actually multiplying by 2 minus I. On top here, I've got to FOIL this thing completely, which means 7 times 2, 14. 7 times negative I, negative 7I. 3I times 2, 6I, and then 3I times negative I, negative 3I squared. Yes. Now, no, not on the bottom.
You're right.
Not on the bottom.
You just multiply.
You just, on the bottom, you just multiply the first terms and then the second terms. So the bottom would be 4 minus I squared. Now, that's the trick, that's the thing. If you're multiplying conjugates, like in the bottom, you just have to multiply the first terms together and the last terms together. But if they are not conjugates, this and this are not conjugates. They're just two different complex numbers. You have to do the full 4-0 method. When it's binomial times binomial. Alright, so let's simplify. Let's finish it. So when we finish this, we can cancel this I squared, right? And that makes this a positive 3. We can cancel this I squared, makes that a positive 1. Don't forget your 1 right there. So now we combine like terms. 14 plus 3 is 17. Negative 7i plus 6i is negative 1i, or just negative I, over 4 plus 1, which is 5. Now, are there any common factors here? No, there are not. So that is the final answer. Alright, I'm going to pause here, and we're going to do some more practice. Alright, this will be the last one that we put on video. So, John, make sure you're focused on this right here. Alright, so we're going to multiply the numerator and denominator by the conjugate of 2 minus 4i. 2 plus 4i. So, in the numerator we FOIL. 1 times 2 is 2. 1 times 4i, 4i. 8i times 2, 16i. And then 8i times 4i, 32i squared. Alright, so the denominator, since we're multiplying a product of conjugates, multiply the first terms, you get 4. Multiply the last terms, you get negative 16i squared. Now simplify your I squareds. So this bottom I squared makes this negative 16 positive. This top I squared makes the positive 32 negative. Alright, so what we have is 2 minus 32, it's negative 30, and 4i plus 16i, which is 20i, over 4 plus 16, which is 20. Now, can this be simplified? What is the common factor? 10 is the common factor. So, this is going to be negative 3 plus 2i over 2. Now, that's as far as you can go. Okay? Now, if I were to break this up into 2 fractions, then it would look like this. Negative 3 over 2 plus I. Because what's 2 over 2? 1. So you could write it like this, but it's fine if you leave it like this. This is the official standard form, but I don't mind if you leave it in this form as 1 fraction. Alright, we'll stop the video there. Well, let me say one last thing before I stop the video. Alright, on the homework 5, go to homework 5. On homework 5, we're going to do 1 through 16 all. 1 through 16 all. Okay? Now I'm going to stop the video.